Good morning, everyone. Thank you for joining our Qnostics webinar. So this webinar is going to be an educational webinar which will focus on the importance of third-party controls in molecular diagnostics. My name is Bryony Boyd and I'm one of the business managers for the European region, and I'm joined today by Dr. Dwaine Vance. He's one of our senior molecular product specialists. During the start of the pandemic, Dwaine was involved in building our COVID-19 testing laboratories here at Randox. So he was involved in validation and verification of the machines and setting up the laboratory. Our COVID-19 laboratory is one of the biggest COVID-19 testing laboratories in the UK and possibly Europe. It had the capacity to run over 120,000 samples per day, and Dwaine was one of the laboratory managers. So just a little bit of an overview of Randox to introduce it. Randox are a world leader in the IVD industry with nearly 40 years experience. Randox products offer clinicians and physicians comprehensive insight into patient diagnosis. We offer reagents, controls, and clinical chemistry analyzers. So just a little bit of a background of Randox. We were founded in 1982 and we are based here in Northern Ireland in the UK. We are privately owned by Dr. Peter Fitzgerald, who founded the company, and we employ over 2,000 people. Our IVD products are used within 145 countries in over 100,000 end user laboratories. And we have a very, very large focus in R&D here in Randox, and we commit over 25% of our turnover each year back into R&D. So just a little bit more information on our Randox molecular laboratory. So back in February 2020, we built a molecular laboratory in response to the growing need for COVID-19 testing in the UK. So Dr. Dwaine himself was involved in building this laboratory. We currently have the capacity to test over 120,000 patient samples per day. So it's a very, very large lab, and we conduct over 20% of the NHS's COVID tests. So to date, this is over 11 million samples. So I'll now pass over to my colleague, Dr. Dwaine Vance.
So Bryony, thank you very much for the very kind introduction, and thank you as well for the invitation to host and to discuss the importance of third-party molecular controls. I have got a wide wealth of experience utilising third-party molecular controls as part of the Randox COVID-19 testing molecular laboratory. So it's important for me as a laboratory manager to understand why we need to use them, the quality importance of using them, and the effective way in which you can use them to ensure that your laboratory gains the relevant accreditation within your particular country. So the title of this presentation is "Why is third-party QC important for pathogen detection and molecular testing?" I will make this presentation applicable to all different types of molecular laboratories. Of course, a lot of people will be focusing on COVID-19 molecular testing, but all of the rules and regulations that I will discuss today are very much transferable across all of the molecular pathogens that are being currently tested, the respiratory pathogens, sexually transmitted infection pathogens, gastrointestinal, and so on. The aim of my presentation will be to discuss the importance of these controls and to provide some examples of how laboratory managers can successfully implement these within their laboratories to ensure that the samples that they're testing produce as robust as possible results. So there are a number of different ways in which laboratory managers can assess quality and improve quality within their laboratory. We all very much know the importance of proficiency testing and external quality assessment. This has been around for many years, and as Bryony, you mentioned, Randox is very well known for clinical chemistry EQA, called RICUS, and Randox also have now got their own EQA molecular brand called QCMD. So the implementation of proficiency testing and molecular EQA is one way in which labs can monitor performance, as well as using your IQC, which are first party and third party controls, but also training staff on a regular basis by continuing professional development and the implementation of a robust and well-structured quality management system. So every laboratory manager should have a protocol and a quality management system within it to ensure that these rules are followed to improve performance. And of course, once these rules are implemented within your laboratory, then that can provide scope then for accreditation and certification within your national setting. So molecular laboratories setting and standardization and quality aims to support competence in diagnostic service provided. It's important because the reliability and reproducibility of patient test results. So with implementing quality controls are effectively, the main aim for that is to improve the reproducibility and the reliability of patient results. If laboratories are not high quality, then the patient results may be inaccurate, and that could have severe downstream effects for how the patient is treated or diagnosed. Improving quality within the lab ensures compliance with appropriate regulatory requirements and accreditation bodies. We know across all of Europe and many parts of the world, the majority of laboratories are working towards common national, international regulatory standards and guidelines, such as ISO standards, CAP accreditation, CEN, CLSI, and IPAC and ENAC, for example. So each country within Europe and beyond will have their own national or international regulatory standards, and by introducing all of the aforementioned quality measures, then these labs will work towards appropriate accreditation status. Internationally, there are increasing demands for molecular laboratories to perform. This has been going on now for a long time in clinical chemistry labs, and it's the same for molecular testing labs. Molecular labs are looking for, if not already, for accreditation under ISO 15189 and ISO 17025 or equivalent. There is a pressure for laboratories to perform to very high standards, or that can result in consequences of failure. And any risk of non-conformance to quality standards could result in a poor accreditation audit and potentially loss of accreditation. And also, just to make note of the European Directive on in vitro diagnostic medical devices, laboratories should ensure that all commercial or in-house tests, such as the multiple PCR tests that we have validated, are shown to be fit for purpose. Laboratories should participate in external EQA, such as QCMD, and undertake the relevant internal quality control procedures. So what that means is that laboratories must look at using in-kit controls, first-party controls, but also there is a demand in modern molecular laboratories to utilize independent third-party molecular controls, because the third-party molecular controls have got multiple different advantages that in-kit or first-party controls just do not have. A little bit later on in the presentation, I will discuss the benefits of third-party controls and what they can show above and beyond the first-party control. So molecular labs are no different to clinical labs. Quality control and quality assessment is crucial. Molecular labs need to follow similar regulatory requirements to that of clinical chemistry labs. This bar chart just gives you a very quick indication of how molecular diagnostics has progressed and evolved over the last number of years. Molecular is growing in proportion to traditional methods such as culture and serology methods. A lot of companies have got molecular specific departments, research and development departments, where they're developing and constructing molecular platforms, molecular assays, molecular controls. So there really is a move towards molecular, and because there's a real move towards molecular and genomics in general, there is an increased regulatory demand. So it's important that we treat molecular labs in the same fashion as clinical chemistry labs. ISO 15189 is an important ISO stipulation to understand and respect in respect to quality. ISO recommends that the use of independent third-party control materials should be considered either instead of or in addition to any control materials supplied by the reagent or instrument manufacturer. So if you're only currently using first-party controls or in-party controls and you're not using independent third-party controls, then I would very much suggest that you consult one of our Randox representatives, and we would be very much happy to provide you with additional information on all the third-party controls that we can provide to you for the molecular laboratory. And if you require any additional Qnostics material, we'd be very happy to help out. The lab should use quality control materials that react to the examining system in a manner as close as possible to patient samples. So again, this ISO recommendation fits very much in line to our Qnostics material that we provide to end users. Our Qnostics material is manufactured to ISO standards. It mimics a human sample very well. It's provided in a liquid frozen format, which means there is no sample preparation required. Some third-party control manufacturers will produce a lyophilized product and ship the end user a lyophilized product. However, this in my opinion is a disadvantage because the lyophilization material isn't as commutable as a liquid frozen product such as Qnostics. Quality control measures should be periodically examined with a frequency that is based on the stability of the procedure and the risk of harm to the patient from an erroneous result. So whenever you are assessing your molecular workflow within your lab, it's important to look at the number of machines you have, the number of staff you have, the opening hours of your lab. Is it a 24/7 lab? Is it a 9 to 5 Monday to Friday lab? And using these variables, as well as looking at the number of samples you process a day, can help you establish exactly which frequency that you should be using third-party molecular controls. The laboratory should choose concentrations of control materials wherever possible, especially at or near clinical decision values, to ensure validity of decisions made. So in regards to the utilization of third-party molecular controls, the Qnostics product portfolio offer a range of different concentrations for multiple different pathogens. So that can ensure that laboratories are testing at near clinical decision values. The lab has to provide the levels of quality control materials run for each day, the frequency of performing the quality control, and the types of QC materials and the QC acceptance criteria. There must be a high importance and should be given to the elimination of mistakes in the process of handling samples, requests, examinations and reports. And of course, with the utilization of third-party molecular controls, it's also important to implement EQA or proficiency testing such as QCMD. And ISO regulations also stipulate that interlaboratory comparison programs such as QCMD should be provided and conducted within the laboratory on a routine basis. And samples provided from EQA programs should provide clinically relevant challenges that mimic patient samples. So although we're spending most of our time talking about third-party IQCs, it's also important to understand that molecular EQA programs should also be used within the molecular testing lab. So there are multiple different international and national guidelines that stipulate and emphasize on the importance of third-party independent controls, and I've just selected a few of them here to discuss. For example, the National Association of Testing Authorities from Australia, they clearly state on their website that controls independent of those produced by the manufacturer of the test or analyzer should be used. And also from the Clinical and Laboratory Standards Institute, they quote within their website that quality control materials should be different from the calibrator materials to ensure that the QC procedure provides an independent assessment of the measurement procedure's performance in its entirety, including the procedure of calibration of the measurement. So again, if you look at the Qnostics brochure, our full portfolio provides multiple different varieties of QC material. We have our QC control material, which is at a medium level. We have our molecular Q panel, which are provided at low, medium and high. And we also have the analytical Q panel, which ranges from very high to very low. And the utilization of these different products are used for different components within the laboratory. The lab should use more than one level of IQC material, i.e. a normal level and a pathological or abnormal control. So again, the utilization of molecular Q panel contains a high, a low, a medium and a negative sample. So this ensures that the clinical range of the assay can be tested. There are a number of different types of quality control practices that can be conducted within the lab. Some labs are currently using first-party or dependent controls, or perhaps they're only using the controls that are built in within the assay or within the cartridges. These inbuilt controls or first-party controls are not true third-party controls, and there's potential for first-party controls to be biased, and that's basically because they're manufactured in non-independent conditions. First-party controls are developed for a specific platform. Other labs, instead of a commercial QC, will be using and making their own QC material using patient samples. Using patient samples can have use within a laboratory setting. However, it's important to understand that patient samples are uncharacterized and do not meet ISO regulations, nor are they traceable to international standard reference material. Also, using patient materials can have stability issues, and there is no standardization for patient samples. For example, the Qnostics material, they're all independently manufactured to ISO regulations. They're traceable to WHO standard reference material where available, and they've all been characterized, and stability studies have been conducted to ensure that the results are as robust and accurate as possible, so QC can be accurately assessed over a period of time. So there are three main strands of quality measurement within the laboratory, and I'm sure that we're all trying and striving for perfection and improved quality within our labs. So you've all seen this image to the right hand side. To ensure accurate and reliable results, the three strands of quality is validation, traceability and measurement of uncertainty. So validation and verification is, have you implemented the correct procedures in place to ensure that you're actually measuring what you're setting out to measure? Has your workflow been accurately validated and verified? If so, how did you do that? What materials did you use? And is your protocol in line with ISO regulations? Uncertainty of measurement. How well do you know the result, what you have measured? Is it correct? And the traceability of the result. How can you compare the result that received? How can that be compared with other results, and how do they compare? Commutability. Does the QC material perform sufficiently like a clinical sample? So when you were conducting your quality measurement, validation, uncertainty and traceability, were you using material that behaved like a clinical sample, or were you using a patient sample? I think for these types of quality measurement, that it's important to use a third-party molecular control which behaves exactly like a patient sample. The molecular market has very much evolved and grown over the last decade, and I would say because of the global pandemic that we find ourselves in, that molecular has even grown and evolved at a pace that we never really expected. The number of molecular laboratories that I've spoken to around the world that have just set up in the last 6 to 12 months is quite unbelievable. The number of testing labs that have started up their own PCR department. Multiple different labs are now moving away from traditional microbiology methods and are moving to multiplex PCR, real-time PCR methods, including next generation sequencing. So there's a real evolution of molecular microbiology, moving away from traditional microbiology methods to automated PCR methods, to moving towards commercial PCR assays. So back in the days before COVID-19, there would have been quite a good number of in-house developed tests, and now there are all these companies are producing quite robust commercial real-time assays. Syndromic testing is becoming much more commonly utilized within molecular and virology labs. So rather than testing for one particular pathogen at a time or a small group of pathogens, we now have the capability of looking at 10, 15, 20 different pathogens within one biological sample. And this is something that Qnostics invests quite heavily in, syndromic and multiplex testing. As some of you may know, we have a technology known as the biochip array technology, which can detect up to 25 different pathogens in one biological sample using our microarray technology. And more recently, we have developed a point of care test, which utilizes multiplex testing, and that has been built in collaboration with our engineer partners at Bosch within Germany. There's also an increased pressure for molecular labs to have accreditation status, and that's why third-party molecular controls are so important. There are more competitive pressures within molecular laboratories, and there is a movement now to increase interest in standardization of PCR testing. This is a quick snapshot of the extremely large diversity of molecular devices that we have on the market. So I've picked out across different manufacturers of different machines that you will see there, but the one in the middle is the point of care machine that I was referring to there a few minutes ago. It is the Bosch Qnostics Vivalytic. It's an all-in-one molecular testing solution which can be used at the point of care. It has the ability to use low-plex and high-plex PCR testing. The PCR testing can either be quantitative or qualitative, depending on the cartridge which you select for your particular patient. And if anyone listening here today is interested in molecular point of care devices, or is interested in learning more about our Bosch Qnostics Vivalytic, then please consult with one of our Qnostics representatives, and we will be happy to provide you more information on our point of care testing portfolio. There are multiple more different types of near patient testing that exist within the market, and I'm sure many of you have heard of these before. Some of them have even made it to the news, and they're being utilised across the world for COVID-19 testing. And an example of that is our own Vivalytic. It's been installed across every continent in the world, and it's been used to test for COVID-19 PCR test within 39 minutes. So it's one of the quickest within the market. And of course, quality control and quality assessment parameters should always be routinely investigated within the lab. This is an important table that I came across when doing my research for this presentation. It just defines exactly and very briefly the importance of maintaining good quality. Accuracy, precision, linear reportable range, the identification of limit of detection. So limit of detection is very important in molecular testing, because if you're introducing a new molecular workflow or a new extraction reagent or a new qPCR assay, then you will need to determine what exactly is the sensitivity of this workflow, what is the limit of detection, what is the number of viral copies that you can detect in a sample accurately. And one way in which you can do that is by running a linearity molecular panel. And the Qnostics product that we have available for determining the limit of detection is known as the analytical Q panel. And then we have other important QC parameters to investigate is sensitivity and specificity. And of course, within sensitivity and specificity, that produces your overall accuracy. So sensitivity is the lowest amount of target nucleic acid that still returns a true positive result, whereas specificity is the ability to return a true negative result when the target nucleic acid is not present. So the development of a molecular quality controls is quite an important thing to discuss. So from the moment an assay is developed to its launch to it being routinely utilized within a customer lab, there are multiple different objectives that we need to investigate to ensure that the workflow is as robust as possible, and that is to determine the sensitivity, the specificity, determine the LOD, the LOQ, look at inclusivity, so ensuring that your assay can pick up what it expects to pick up, the exclusivity, to make sure that it doesn't cross-react with any other pathogens. So how can you tell for sure that your assay is inclusive and exclusive to what you expect it is? And this is particularly important for anyone from a manufacturing background. If you're working in a molecular manufacturing company, then the utilization of third-party controls should be used to ensure that your assay picks up exactly what it does and it doesn't cross-react with anything. So for example, with the COVID-19 PCR assays, a lot of the assays has used all the other human coronaviruses that have previously existed to ensure that the COVID-19 particle does not cross-react with any of the previous coronaviruses that may be circulating within that human population at that particular time. And linearity, so what is the upper and what is the lower and upper limit of detection for that particular assay. And of course, whenever these assays are being implemented within labs, then the lab will be conducting their own verification and validation process. And quality control materials can also be used for effective training of staff. So if you have new staff coming in that need trained, then to utilize third-party controls to ensure that the results that these new staff are producing are robust. So this example of this image here provides just a quick snapshot, similar to the previous image actually, where we have grouped verification, validation and method implementation into 3 different components, and you will see the importance of each of these different objections within this image. So for verification, you will see that it's important for verification that you can accurately evaluate and establish your method. For your method validation, you will want to ensure that the clinical results are what you expect, and then for method implementation, that you have got you've implemented a method that is fit for purpose and can be used for routine clinical use. And again, the Qnostics material that we provide really does help with incorporating our materials into your workflow. So why do people use third-party controls? And I think this is probably one of the most important slides, because I have had conversations with multiple people and they are using first-party controls, and sometimes they're always interested to know why they should use third-party controls. Quite simply, third-party controls monitor the precision of results from test kits and non-commercial assays. Third-party controls assist in the prevention of errors by constant and consistent monitoring. Third-party controls can assess variation between lots of reagents by detecting shifts and drifts within the reagents. Third-party controls can provide an independent mechanism to ensure that results are as reliable and robust as possible. And third-party controls give the end user the option to apply just-in-time corrective actions to help eliminate errors that may occur during a particular process. Third-party controls are whole process controls. So first-party controls don't go through the full molecular workflow, whereas third-party controls go through extraction, PCR, and pathogen detection. And third-party controls mimic the patient sample. So it's important that third-party controls are commutable and behave in a similar fashion to what a patient sample would. Another important question which we run into when speaking to end users and laboratory managers is how often should they run third-party molecular controls? The frequency in which they run third-party controls depend on a number of different variables, the number of samples it processes per day, the number of staff, or it can also be down to the economic viability. What can the lab in that particular country afford to run at that particular time? But as a general advice, positive and negative controls should be tested each time patient samples are tested. So there should be at least one positive and one negative control to be tested each time, and I would say that would be as a bare minimum. At least once each day the patient samples are tested, the laboratory must include the following: at least 2 control materials of different concentrations if the assay is quantitative, and a negative control material and a positive control material if the assay is qualitative. And the reason why it's important to have 2 different control materials at different concentrations for quantitative methods is because, of course, within molecular you're provided with a quantitative result such as copies per mil or a CT value. And it's important that we can trend these CT values across different analytical runs to ensure that there's no shifts or drifts detected that might pick up maybe an issue with a reagent lot. The molecular assay workflows are very complex, and that is the nature of traditional molecular workflows. The traditional molecular workflow is separated into 3 different subunits. You have your extraction facility, your amplification PCR, and then of course at the end you've got your detection fluorescence, which will determine the negative or positive status of a particular patient. There are multiple different extraction platforms, as there are multiple different amplification platforms. Some of these amplification platforms can be endpoint PCR, where there is a yes/no result at the end, or some of the amplification platforms are combined with detection, where a real-time PCR is produced to produce a CT value to produce an indicative result of the level of infection. And you also have integrated systems that can combine all of these 3 methods together to produce a result. And now more recently, you've got cartridge-based systems and point-of-care systems. So there's multiple different combinations of molecular workflows within the market, and this can have an impact on variation and standardization issues. So it's the utilization of third-party controls are even more so important because of the complex nature of all the different assays that exist within the market today. The first-party internal kit controls, which I'm sure you're all using at the moment, you will be aware that they do not specifically monitor the lot-to-lot variation. This image here will show you that the results of first-party controls, where there appears to be some sort of bias where it cannot detect any potential shifts or drifts. So if laboratories are utilising third-party controls, then they can clearly see any potential shift or drift within their procedure. Not all kit controls or first-party controls go through the whole process, so they may only be possibly PCR amplification controls, so it's completely bypassing the extraction platform. So any issues that that may be present within the extraction platform will not be able to be identified because your in-kit control may only be from the PCR stage. Third-party controls monitor the whole process. So in this process, you will see two boxes, a red EQA challenge 1 box and a blue EQA challenge 2. And the utilisation of third-party controls enable you to detect any shifts or drifts within your control. So if you were not using third-party controls, then you would have missed all of that variation between the two EQA challenges. So how can Randox help? Randox help can help you in your lab quality system by providing high quality, robust and ISO accredited level third-party control material to help you with your method evaluation verification. We can provide analytical Q panels to help you with your linearity, LOD and LOQ assessment, and we can provide you daily run controls that will help to look at your daily Q control quality for each analytical run. So at the end of the presentation, I'll go into more about Qnostics specific information, but this table is just to demonstrate that Randox can provide to you the appropriate third-party controls to validate and verify your molecular workflow. So the Qnostics portfolio is very expansive and very diverse, and we're one of the molecular companies that can actually provide the most amount of different pathogens for your laboratory. So we've got over 40 control products for transplant associated diseases. We've got over 20 products for respiratory disease, including COVID-19, influenza A, B and RSV. We do a whole host of bloodborne virus material, such as HIV and hepatitis. And we also do sexually transmitted infections, such as chlamydia, gonorrhea. And we do meningitis, sepsis, gastrointestinal disease products as well. So if for any laboratory that is testing the molecular assays, conducting PCR workflows, then it's very likely that we have a control material that will be applicable for your quality management system within your lab. Third-party controls measure accuracy and precision of the entire molecular workflow, which first-party controls don't. Third-party controls can determine lot-to-lot variation, which first-party controls don't. Third-party controls can assess genetic diversity. They can also assess linearity, limit of detection. They can detect any potential shifts or drifts that may be present within a workflow. They can ensure accuracy of the entire testing process, and that is because the Qnostics material that we provide to our end users are whole pathogen. So they contain the full viral genome, and they can help determine the true specificity and sensitivity of the assay. Okay, so I'm just going to finish off by giving just a few more maybe examples of how I in the Randox testing lab conducted some of my daily QC. So you'll see from the middle of the slide here a 96 well plate, and because Randox is very much a high throughput testing laboratory for COVID-19, a lot of our work was conducted on traditional 96 well plates. So you'll see from the well A1, well A2, H11, H12, we had a total of 4 controls. So that 92 clinical samples per plate with the addition of 4 controls. And the addition of these 4 controls really helped us to ensure that our results were as crystal clear as possible, and that the results that we gave to our patients were very trustworthy. So in well A1, we used Qnostics negative control. So the Qnostics negative control is a true specificity negative, which you would expect to throw up to produce a negative result. Now, the negative control product doesn't necessarily have to be in every run. You can also use nuclease-free water to determine your negative extraction control. But we used about, I would say, 90% of our plates we used a nuclease-free water negative control, and then 10% of the other plates we used a negative extraction control, which was a true specificity negative control material from Qnostics. And the catalogue code number for that material is TMNQC. Within well A2, we used a positive extraction control, and for the particular product that we used for this control was the Qnostics SARS-CoV-2 Q medium control. The catalogue number for that was SCV2QC, and that was in well 2. So every plate had a negative extraction control and a positive extraction control, and that was to determine your extraction process, and to ensure that your extraction process was not contaminated, and to ensure that your extraction platform was actually working the way that you expected it to work without any issues. Your extraction controls are whole pathogen controls and can work on any molecular workflow, and they can be used across all the range of COVID-19 PCR assays. The PCR assays that we used within Randox were the Randox qPCR assay, and that assay looked at the E gene and the ORF1ab gene as well. And because the Qnostics material is whole pathogen, then they work perfectly with the Randox qPCR reagent. We also utilised a PCR amplification control. The negative PCR control located in well H11. So your negative PCR control is supplied with the Randox real-time PCR kit. And again, that's just to ensure there's no contamination within the setup of your master mix, your PCR master mix. And also we added the positive PCR control. And your positive PCR control is only partial genome, or it's synthetic RNA, which is there to aim to look at your PCR testing process. So it's not a whole process control, it's just your PCR amplification control, which is used at just above the limit of detection to ensure that your assay is picking up samples across the full clinical ranges. And then you will have your internal inbuilt controls, and this is essentially within your qPCR kit. You will have a primer probe. You'll have a pair of primers and a probe contained within your assay to ensure that the swab sample was taken correctly, and that the workflow has conducted effectively as well. And if the patient sample is not positive for the inbuilt human control, then that sample will need to be repeated. And that might result in a new swab being taken by the patient. So Qnostics controls, there are different varieties of Qnostics controls. You've got your Q controls, which are in this slide, and then you've got your molecular Q panels, which is on the next slide, and then analytical Q panels that are on the next slide after that. So your Q controls are very simply put are positive run controls, and they're based on the medium concentration level at the clinical range. So you'll see from the image of the left-hand side, there are 6 different samples, and all of these 6 samples produce medium levels of concentration. So this is how the kit is provided to the end user. 6 files of medium controls. These Q controls are positive run controls that are intended to help laboratories monitor their molecular diagnostic assay on a run-to-run basis within customer-derived limits. Third-party independent external controls will ensure that assay drift is detected, monitored and managed, allowing the lab to continue to provide accurate and reliable results. They also help support a lab regulatory requirements under standard ISO 15189. These whole pathogen controls can be used with any molecular assay regardless of the target gene selected. The next type of molecular control provided by Qnostics is your molecular Q panel. And you'll see from the image below that there are different concentrations of samples provided here. They're not all mediums. You have one medium sample in this kit, one high sample and one low sample in this kit. You also have a true specificity negative as well. So 4 samples within this kit, a negative, a high, a medium and a low. These molecular Q panels intend to help laboratories evaluate their assays' analytical measuring parameters and monitor their molecular diagnostic assay procedures. Molecular Q panels can also be used to support laboratory training and in the assessment and development of molecular diagnostic assays from extraction through to amplification and detection. And thirdly, you have your analytical Q panel, and you will see from the image on the center of this slide that there are 7 different samples provided in this Qnostics kit. You have got the 3 same samples from the molecular Q panel, but you also have an additional number of samples there as well. So you've got samples that are very, very low, and you've got samples that are very high as well as samples in between the low and the medium, and a sample in between the medium and the high. And these analytical Q panels, they are also referred to as a verification panel. They can also be referred to as a linearity set. But these panels are designed to cover the dynamic range of an assay, allowing labs to assess linearity, limit of detection and LOQ of their assay. Each panel contains samples covering the dynamic range of most assays in a linear progression, all of which should be treated as a patient sample within an assay run. So there are multiple different ways in which these types of controls can be used. These are only some of the specific uses of how I used some of the Qnostics products as part of my time as laboratory manager at the COVID-19 labs. So it was to assess lot-to-lot assessment of nucleic acid reagents or real-time PCR kits. Controls should be used to ensure that previous lots of reagents are comparable to new lots of reagents based on the true positive and true negative results assessing single and multiple gene targets. So we want to be able to comfortably say that any new lot of reagents that is coming into the lab, that before we can actually use these reagents for clinical testing, that we need to conduct some form of assessment using third-party controls. Molecular controls are useful in the clinical validation of equipment. So if you are getting a new extraction platform, or if you are getting an old extraction platform upgraded or serviced, then it's important that you carry out validation studies or post-maintenance calibration checks to ensure that your extraction platform is working and is reliable for molecular testing. Molecular controls were also used for the effective training of staff. So how we did this within our own lab was we trained our staff using 96 well plates. 70 of these samples were water, and 20 of these samples were Qnostics. So once this training procedure was completed, we looked at the results of the 90 samples, and if the scientist was trained effectively, then the 20 Qnostic samples were positive, and they were positive within a specific range of CT value, and the 70 water samples were all negative. So this was just to ensure that the scientist was able to follow a standard operating procedure. They had good laboratory practice, and they have been effectively trained in how to pipette at accurate levels of reagent and sample. Analytical Q panels, such as those supplied by the Qnostics, these were used on multiple occasions to assess linearity and LOD of an assay. So anytime we got in a new extraction platform, and of course at the start of COVID-19 there was real issues with identifying extraction reagents, extraction machines. So we had, at the very start of our adventure, when we were establishing our lab, we had a number of different extraction platforms. So to determine the LOD and the linearity of these extraction platforms, then we utilised analytical Q panels, as well as qPCR assays. If we were utilising a new qPCR assay within our lab, we used an analytical Q panel to determine the linearity, the LOD of that assay. Furthermore, the latter stages of our testing lab, we moved towards an automated liquid handling robotic system rather than using manual PCR methods. So to establish the comparability between the liquid robot handling systems and the manual processes, we utilised molecular Q panels which contained high, medium and low samples. And this was just to ensure that the robotic systems that we were using were accurately pipetting the correct samples into the correct wells, and we were able to determine the efficiency of this procedure by looking at the known CT values of the samples. We were able to accurately and comfortably determine that there was little or no crossover contamination using robotic systems when compared to using well-established manual protocols and processes. And also during my time as lab manager, we conducted some R&D work, and that was the development of the Randox extraction kit as well as the Randox qPCR assay. So the R&D of these particular products were all accurately verified and validated using Qnostics control material. This is just some screenshots from the brochure. You will see the SARS-CoV-2 medium Q control is provided in 5 vials at 0.5 ml each, so that's a total of 2.5 mils, and that's stable for 5 days once it's thawed and stored in the fridge. And you've got your molecular Q panel, which is 4 vials at 0.5 ml, so that's your high, your low, your medium and your negative. And then you've got your analytical Q panel, which is 9 different vials, so that will be 8 vials at varying concentrations plus 1 negative, and that is also at 0.5 ml. So these products have been CE marked and are readily available off the shelf. And if you require more information on how to order these products, then please consult with our Randox representative, and we'd be very much happy to provide you some quotations. And I think this may be my last slide now, but we also have some coronavirus products from Qnostics that are available in a multiplex format. So we have got RTX1, RTX2, 3, 4 and 5, which are 5 different products. And on the right hand screen you will see product number 1, which is called your RTX1 control, and it includes 5 different vials, of which 4 of those vials contain influenza A, H1N1 strain, influenza B, RSV and COVID-19. So we know a lot of commercial assays are now starting to do multiplex assays, and this control provides users with an all-in-one QC solution to test the robustness of their platforms. So thank you very much for listening, and I hope you enjoyed listening to how I implemented third-party controls into my lab and the importance of using third-party controls. And thank you to Bryony for inviting me to do this presentation. And if you have any follow-up questions, then I would be very happy to take them either now if we have time, or you can email myself at dwaine.vance@randox.com, or you can email Bryony, or if you want to also email marketing@randox.com, and they can put you in contact with the right person within the company. So thank you for listening.